Okay, this question 4, we've firstly got two modulus graphs to draw. So this is the simplest modulus graph you ever get, so you just need to know what shape y equals modulus of x is. Okay, it's a V-shaped graph. We need to do them on the same set of axes. So if you want to sketch them separately, you can do, but put them on the same axes afterwards. This second one here, okay, you can either do it by transformations based on the first graph, but because both of the transformations are inside and are acting horizontally, we're going to be doing the stretching after the translation, and that will affect the point of the V. So you might want to use, I would recommend in fact, doing the method where you work out what the point of the V is, okay, and what the y-intercept is. And those two things normally, if you work out where the point of the V is and where the y-intercept are, then you will be okay. Okay. Then we've got to solve the equation first thing equals the second thing. So these two graphs have got to equal each other. So if you've got two V's that intersect each other, now I'm not saying the graphs look like this, okay, in fact I think they don't, but the idea is that we can see from the graph the points of intersection, and therefore we can see that there are actually four separate graphs here. There are two things here and there are two things here, because a modulus can always have no effect or it can have an effect. So modulus of x could always refer to either x or to minus x, depending on whether x is positive or negative, and modulus of 2x minus 4 can decode into 2x minus 4, no effect, or minus 2x plus 4 if the modulus has done a sign swap. So that can, in some cases, potentially lead to four different equations that you would have to solve. But there are only two intersections here. Okay, so what's quite a good idea is to work out which of these possible equations applies to the downslope and to the upslope of each graph, so that you can actually identify the specific equation here, whether it's a sign swap or not, and the particular equation here, okay, that you'd need to solve to work out that solution. Okay, I think the graphs in your particular case are kind of the other way around. Okay, but the diagram should help you. Okay, and then finally, hence, so these points here are the critical values where this thing equals that one. We will now want one graph to be bigger than the other. So you have to work out which of your two graphs is this one, and you want that one to be higher up than the other. So if you've got two graphs, okay, then if I want this one here to be the one that is greater than the other, then the places where it is greater than the other is where I could stand on this graph and drop stones to land on the heads of the people on the other graph. So this would be a good bit of the graph that I want to be bigger. This wouldn't, because it's below the other graph, but this would be a good bit. Okay, so for these curves here, the section between that x value there and this x value here, this would be part of my solution. Okay, and then the value from that solution for x, that intersection point, onwards, if it carries on being higher up, then all of these will be good ones. So you need to pick out the bits of your sketch where you're showing one graph being above, higher up than the other graph. Okay, so I hope that helps with that one.